Hello, my name is Mukesh Dasri and I'm gonna cover Zookeeper. So Zookeeper was originally developed by Yahoo research team. It's an open source Apache project, which is basically a distributed coordination service used for managing lots of servers and hosts. It coordinates and manages services in the distributed environment with the help of APIs and simple architecture. It basically maintains common objects which are needed for the larger cluster environments, and these objects majorly include the hierarchical naming spaces, configuration information, and so on. Now, talking about the Zookeeper architecture, the services are replicated over a set of machines, and in every machine's memory, the copy of data is stored. At the point of service startup, a leader is elected, and as you can see in this diagram, the client is connected to a single Zookeeper server, and this connection is a TCP connection. The read operation is done from any Zookeeper server, whereas the write operation has to be done through the leader, and which also needs a majority consensus. Now coming to the Zookeeper services, there are 6 Zookeeper services. The first one is cluster management. It basically handles the real-time joining and leaving of any node from the cluster. Second one is the naming service. It basically uses name to identify any node in the cluster. It is similar to a DNS, that is domain name service. The third is configuration management. It basically provides latest system related configuration information for any node who is joining the cluster. The fourth one is leader election. In this, a leader is elected among the cluster, which basically coordinates the system. The fifth one is locking and synchronization service. In this, the data is locked whenever it is being modified. It basically helps for easy connection to other distributed applications whenever the failure occurs. And the sixth one is highly reliable data registry. So even if some of the nodes are down in the cluster, the data is still available uh, through the other nodes. So this is what the data registry service is called, and these are the services. In this slide, we're going to talk about Zookeeper data model. As you can see on the right hand side, the Zookeeper data model is a hierarchical data model which basically follows a tree-like structure. Every node in this structure is called a Z node, which is a data object, and basically client can manipulate it. And every Z node has its own path, and Z node may store a data, any kind of data, or it may store multiple Z nodes as well. And this Z nodes can be manipulated using the Zookeeper's APIs, and every Z nodes can be watched for any kind of changes in that node. At last, we're going to talk about the functions of a Zookeeper. So, Zookeeper keeps a track of information which has to be synchronized across the cluster, across every node. So whenever the partial application failure happens in the cluster, that might be due to master crash or worker crash. So we'll consider first master crash. So whenever the master crashes, to keep the consistency in the cluster, the Zookeeper keeps a track of the master, and now it has to select the next master. So among the other nodes, it allows only one node to be the next master among the rest. And when the worker crashes, so basically what it means that the Zookeeper is not hearing anything from that worker in a while, and so it notifies everyone, like every other node, about the crash, so that work redistribution happens smoothly in the cluster. So my question is, what type of data does Znode stores? So every Z node in the cluster, it basically maintains a stat structure, and that structure contains version number, action control list, timestamp, and the data length. This is what the data that Znode has.